There we go. So when we talk about projections, we have two different types of projections in general category. There's interrupted and uninterrupted projections. So an uninterrupted projection, which we're about to see some examples of here next in this next slide, they're projections of the globe as it's expanded onto a flat surface, meaning that the poles, both the North and the South Pole, are put intact. So we're not divvying up the northern and southern regions. It's not cut up just like you would if you punched a hole in a soccer ball and you flattened it out, you'd have some pieces or octagons separated from the others. That would be an example of an interrupted projection if we would do the same thing with the Earth. For an uninterrupted projection, we're essentially keeping the northern and southern poles intact while expanding out the equator. But the problem with these uninterrupted projections, they create distortions of land masses and actual size. In addition to that, just like you saw in the video, that's no joke. The Mercator projection does distort the size of Greenland as compared to Africa. And we're about to see that here in a second, okay? Hey guys, I know there's comments being made in the Google Meets, but once I'm done with this, I'll go back and answer them, okay? So, we talk in these uninterrupted projections, there's projections of what we call cylindrical projections. And we're going to show a couple of examples right here. Cylindrical means that we are, and I'll go ahead and bring it to this one. Cylindrical means that we're putting the globe into the perspective of how it would be in a cylinder. You see right here at the bottom where the globe is essentially put into an imaginary cylinder. We focus one particular point on the North and South Pole and look at the side view of that cylinder all the way around. So that way it can look just like this right here. So this is an example of that Mercator map that was shown. And what are some things, and I'm going to go ahead and ask you guys right now, just shout it out. Don't put it in the chat, but shout it out. What are some issues with this projection?
The South Pole is too big.
Yeah, Antarctica is like taking up the whole map, right? Anybody else? What is something you notice about everything that's closer to the equator?
When it's closer to the equator, it gets smaller, but the further away it is from the equator, it gets stretched out larger.
Hey, nailed it right on the point. Right on the point. So, yes, you can see that, yes, Europe is getting larger and South America is looking a little bit smaller. But in reality, they said in the video, but yeah, in reality, Europe is really small compared to South America. Same thing with like Australia. Australia is actually, yeah, I don't know the exact size comparison, but Europe is actually about the same, if not a little bit smaller as far as square mileage to Australia. And Antarctica is not this big. Essentially what we're doing is putting the point at the South Pole of Antarctica and open it up like a butterfly. So that's why you see Antarctica like explode out like this. Same thing with Greenland. Why it's elongated out and expanded out when really we can fit a few Greenlands into Africa, 17 as a matter of fact. So this would be an example of a cylindrical projection that's uninterrupted. You also have other examples like the Platte-Kerr projection, which they try to keep it from being too elongated, so that way they can make sure that the size distortion is not impeding the sizes of Africa and South America. But what do you still notice about Antarctica and Greenland? And I'm going to open this up to anybody. What do you still notice about the poles?
They're still kind of stretched.
Yep, they're still stretched, and this is oh, go ahead if anybody else was trying to chime in. Okay, so these are examples of cylindrical projections, meaning that we try to put the Earth in a cylinder and look at it from the side view. But as you know, there's the points on the North and South Pole are going to be curved, meaning that the land mass when it's projected onto a flat screen, it's going to be elongated. It's going to be stretched out. All right, pseudo-cylindrical projections. These ones look a little weird, but I'll show an example of this one right here. So a pseudo-cylindrical means that we're still putting the Earth into that cylinder. However, instead of elongating out the poles, we're going to keep the poles intact, and we're going to make it the central median of focus on the northern and southern points. So you can see here that Greenland may have a more relative true size compared to Africa. Same thing with Antarctica. But I want to ask you guys right now, what is the problem you see with this projection?
If you look at the Americas, it's really like stretched or like bowed out, and therefore would make it very difficult if you were looking into the Americas to navigate.
Absolutely. That last part was exactly true about it's difficult to navigate. Anybody else had anything?
The perimeter of the map, like all the countries on the outer sides, are kind of just stretched out according to the sphere. And then, as you see, if you look at Africa, which is in the middle, it's just kind of unbothered.
Yep. So even though even though we're projecting it at this point, it's in our central focus. But if we rotated this projection around, maybe Australia, and if we rotate the other way, like Alita was saying, we could probably see North America a little bit better and South America. But Africa would be stretched out in our projection so much that it's hard to navigate, it's hard to reference to. So this is the strengths and weaknesses of the pseudo-cylindrical projections. They just try to eliminate or they try to limit the amount of distortion of the surface's size, but it's harder to navigate. So in your notes, you're going to see, sorry, I dropped my ring. In your notes, you're going to see in the projections, what are the weaknesses and strengths of a projection? So you'll be able to put that in your notes. And guys, I know as you're going through the notes, you may see, what should I put for this blank? What should I put for this blank? Leave those for the end of the class, or just ask me in a Google Classroom comment or a Remind one-on-one text, and I'll help you. Okay. So now, hold on a second. Yeah, these are the last types of pseudo-cylindrical maps that we're going to discuss. The Molly-Wade projection, sorry, and then the Robinson projection, and then we're going to go into our interrupted projections next. So this one right here, I want to just get somebody's perspective real quick. Should this be a good map that we use? Yes or no?
No.
Okay. Do you have a particular reason why?
Not really. I mean,
You mind if I help you out?
you know what? You know what?
No,
Yeah, I think it would be good to use.
yeah. No, I don't ever want you to go back on what you said. You mind if I help you out though?
Yeah.
So, what if I were to ask you today, hey, I need to find a reference point about where Raleigh, North Carolina is in comparison to Houston, Texas, and I want you to draw for me a detailed route from Raleigh to Houston using this projection of Earth. How would that route look? Do you think it looked distorted at all?
Mm, no.
Unfortunately, with these projections, with the pseudo-cylindrical projections, they actually would. Because as you can see here, even though the equator is shown right here and the equator is trying to show less distortion, you're going to get more distortion in the middle sections, especially right here, like you would in South America, Australia, and America. instead of having a flat area where I can see how my route's going to take me, I'm probably going to get distortions of where that route's going to go. It's going to be elongated. Does that make sense?
Yeah, it does.
So that's the reason why these projections have a weakness like that. Just like this one, and same thing with the Robinson projection. So the main reason why we use these two is because of how we draw out the latitude and longitude lines on them. So in this mollyweed projection, we have the excuse me, latitude lines that are going to be drawn straight. However, the longitude lines will be drawn at a curve. So it's really hard to predict where absolute location is when you have latitude lines that are straight and longitude lines that are curved. Same thing with the Robinson projection. This is what those weaknesses are. And somebody was about to shout out something. Go ahead. Anybody have anything, or you just have your mic on? Okay, I'll just assume you have your mic on. Same thing with the Robinson projection. Even though in this projection here, instead of keeping the central points of the North and South Pole central and keeping it at 1 like you saw in this one, on this one, they're going to elongate out the poles like we saw earlier in that Mercator projection, but same thing here. We're going to have the latitude line straight, but the longitude lines curved, which makes it much more difficult to navigate and much more difficult to find absolute location. So these are examples of uninterrupted projections. Next one, interrupted projections. This is how you would literally take that soccer ball, punch a hole in it, and cut it out into pieces and create what are called missing pieces or missing wedges. And I'm going to show you an example of one right here, and you're going to look at it and be like, what the heck is that? So in an interrupted projection, we remove parts of the Earth called wedges to create a flat surface as to eliminate this distortion, period. It's not perfect, but it is the best as far as eliminating distortion. However, I want you to look at this map and tell me if you can literally navigate with this. How many of you guys think you can navigate your way around the world with that?
Depends on where you're at.
No.
I don't know who said that, but whoever said depends on where you're at. I like that point. You may not be going far at all, because in this map right here, the distances between points that are short may not be as distorted as for, say, the Mercator map if you're closer to the equator. Now, if you're further up into the northern or southern hemispheres, it's going to be much more difficult to navigate through. And this is why most maps like Google Earth and mapping systems that we have for ships, this is why they always use the Mercator or the Robinson projections, because it's easier to navigate through that. Most maps will use Mercator because it's easier to navigate. However, we understand now that the northern and southern poles have been elongated and stretched out, distorted to such a degree that it doesn't show us true size. And this goody projection, I always like to call it the goody homos lowest. That last part I really always have a hard time pronouncing, but it's really called the goody projection.